Can you guys see me?
Are you asking
Uh,
myself?
yeah.
I can see
Yes.
you. I can see Dr. Tapioca Weasel.
Doctor, because he is a doctor.
Oh, Doctor!
All right. So, you were explaining this bad faith actor.
Yeah. So let me just get his face on here. So this is the guy that we're responding to. This guy, he runs a YouTube channel, Sky
Hello.
Scholar, and it's this guy right here. Okay, so this is Dr. Pierre-Marie Robitaille. Now, I probably said that wrong, but yeah. And this is an individual who is extremely perplexing to me because it's not an unintelligent individual. It's not an unqualified person. It's somebody who should absolutely know better than what is coming out of their mouth. Okay, and he has a legitimate PhD in something. I don't know exactly what the PhD is in, but I know that he
Be nice
made
to know.
really important advances. I can look it up really quick.
So it's
Um,
not in like
I'll bet
scientism,
it's not
right?
astrophysics.
no, it's not astrophysics. It's not astrophysics, but he invented or developed a major advancement in MRI imaging,
Wow.
and like the on Rational Wiki has a page on this guy, which I can probably just briefly show really quickly. Let me share this instead. So he's an accomplished radiologist, and he was a director of the MRI research at Ohio State University. He made major advances. He's somebody who, if he had been awarded the Nobel Prize in medicine and physiology, like that would make sense. Like, and that's why they probably lead with he's a Nobel disease type crank, because guy totally lost it. He was they asked him to resign in 2000 because he started advocating for these really crazy fringe astrophysical concepts. But it's very puzzling. And I don't know how to switch it, so I'm just going to unshare and then reshare. And here is so we're watching video something in the playlist, and this playlist is about his take on the cosmic microwave background, and his basic like hypothesis is that we're always just measuring the ocean. This makes no sense. This makes no sense on like 8 different levels. But yeah.
Stephanie,
So
I'm so glad you're here.
yeah.
I'm pulling up. I'm trying to find the shortest video with Alan Guth in there.
Right?
You know, I'm just trying to find like 2 minutes of Alan Guth basically going, "Fuck you."
Yeah. No, so Professor Dave, by the way, a couple of years ago did a 40-minute long video debunking this guy, which is fantastic and will go into more detail than we will be able to go into here. But yeah.
Hello, everyone, and
So
welcome to Sky Scholar. Today, the series on the microwave background continues with the discussion of the results obtained by the FIRIS and DMR systems on the COBE satellite.
so the Kobe satellite was launched in like when was it launched exactly? In like the early 90s, I want to say.
Kobe. When was Kobe?
It 89 to 93
Yeah,
Okay.
is when it was operating.
yeah, it was late
Previously
80s, early 90s.
Yeah, and it was there to measure this. So the cosmic microwave background, for anybody who doesn't know, just very briefly, the idea is that after the Big Bang, the universe was opaque for a long time, and then it became transparent. And at that time, it was basically more or less all in thermal equilibrium with itself, the various parts of the universe were. And when it became transparent, that light just kept propagating forever. That black body radiation light just kept propagating forever. And now we see it, and it follows a particular curve that says that basically the background temperature of the universe is around 2.73 Kelvin or so. And he's like, nuh-uh, basically.
Yeah. So a little bit of background, more background. People started to notice that. Two radio astronomers, Penzias and Wilson, were working for Bell Labs, and at the time they had a great big huge microwave antenna in right around in 1965, and Bell Labs was using microwaves to do telecommunications at the time, right? And they kept hearing this stupid hiss, and they couldn't figure out what the fuck it was coming from. They were driving them nuts. They were going pigeon shit wild. and literally, because pigeons would go into the thing looked like a great big horn.
Yeah.
Like a huge horn of plenty. And the pigeons would go in there, take a dump, and so they figured it's gotta be the chicken shit. So they went in, cleaned the whole thing out of chicken shit, and still it was there. They couldn't figure out what it was. They finally figured out that it was this thing. It was this noise that they were hearing in the microwave area of the radio spectrum. That was this coming. It was the same coming from every single direction. It was exactly the same all over the place. And so they thought,
yeah,
this was this, and they got a Nobel Prize for figuring that out. So we'll see if this fellow gets a Nobel Prize for figuring out something.
If he is right, and he proves him, and it's proven that he's right before he dies, he will win one. But he's not right. So this, by the way, is that microwave antenna that Stephanie was mentioning. That might be Penzias and Wilson. I'm not sure.
I don't know.
But it's a giant thing that reflects a bunch of the microwave radiation into this thing, and then it hits basically another thing that then records it somewhere. But it's a big metal.
That is it, and that's them.
Yeah, and it's pretty neat. And when they turned it on, yeah, there was just this background hiss, and they were like, well, what is this? Anyway.
By the way, that background hiss was, we don't see it anymore because, we don't have CRT, which doesn't mean critical race theory in this context. It means cathode ray tubes. When TVs were like that, if you were in between the channels, or there was no chip, you were in some place where you weren't getting that particular channel, part of the stuff you saw on the screen was the cosmic microwave background.
Yep.
Exhaustive analysis of the Cobe-Fearus measurements in this paper, and I urge those who are interested to consult that resource. It is simply not possible to cover all the issues related to each satellite in a reasonably compact video series. I am trying to provide a solid overview, but for those interested in studying the details, you must move beyond the videos. In Cobe, or radiological analysis, not only are details about the Cobe satellite provided, but I also emphasize problems with rushing the instrument to launch and the ever-present concerns relative to water contamination in the microwave background measurements. Cobe was launched in 1989 and positioned in polar orbit around the Earth at an elevation of about 900 kilometers. Cobe has a heat shield, but this shield is designed to provide Earth's infrared radiation from affecting the instruments on the satellite. The shield has no ability to stop microwaves from diffracting into these instruments, including the all-important Fearus horn.
Now, this right here is sort of his fundamental issue with the Cobe satellite. So the Cobe satellite goes up and it points a microwave horn like we just had on the screen, but it points one of those, and smaller, just out into space. And then you perform measurements. And his point is that it is going to be influenced by microwaves coming from the ocean and hitting this thing and bouncing around and into it.
Why would he think that?
Because I don't know. I don't know why he thinks that. That's what's so frustrating is he not in this video, but I spent a lot of today watching videos of this guy, and he'll find quote after quote after quote of people being like, "Oh, by the way, like water vapor in the air, Penzias and Wilson, like when they were measuring it, water vapor in the air would make their reading go up, and they were like, oh, great, that means it's working because we know that it can be a source of noise." And yet, the people that he's appealing to be like, this is a source of noise, are also the people he's saying didn't account for this source of noise. Also, the source of noise, fundamentally, just wouldn't do what he's claiming it would do. And he's saying that this satellite, which is able to, because he thinks that this shield is going to prevent the IR radiation, but not the microwave radiation. That's like mostly silly. It's not totally silly because microwave radiation is at a lower wavelength and it might behave in a near field way as opposed to a far field way, but it's really dumb.
Is it totally bullshit?
It's 99% bullshit.
I'll take it.
Yeah. And mostly what he's saying...
You got me on the field stuff, but clearly this man is outstanding in his field, so...
Yeah, that's the thing, is he
just doesn't happen to be his field.
Yes. And I think that possibly it is slightly closer to my field than it is to his field, but it's not like crazy closer. Like nuclear magnetic resonance imaging has a lot of physics. It's not a lot. It's just nuclear physics, which is not radio astronomy. This is radio astronomy.
Mm-hmm.
Fearus was famous for having obtained the...
Fearus, by the way, stands for something absolute photospectrometer. And it's the thing that basically says, okay, when we point at this spot in the sky, we're measuring this whole spectrum. He's going to show a spectrum,
body radiation curve ever, as you can see in this figure.
So this is the data.
Hawking stated that this represented the discovery of the century, if not of all time. Indeed, the COBE authors are proud to claim that their measurements had such high signal-to-noise that one had to blow up the error bars by a factor of 400. That their measurements had such high signal-to-noise.
This is data. This is data with a line of interpolation through it. But with the fit line, the data points are on there. It's just that their error bars are so small that you can't see them. This is
yeah. I do
incredibly.
I think
that one had to blow up the error bars by a factor of...
When you blow up the error bars 400 times, then you can see them. It's astonishingly pristine, beautiful data. And it looks exactly how you would expect it to look. And there is no comprehensible reason why you would get such a precise match to this particular shape if you were just looking at a parasitic signal from Earth's oceans. It makes no sense.
400 just to be able to visualize them. Now that is signal-to-noise. In fact, it is nearly unparalleled signal-to-noise for such measurements.
Mm-hmm.
But in this regard, I have a note of caution. Powerful signals employ proximal sources. Be careful to make cosmological claims based on signals measured near the Earth, especially when the possibility of diffraction has not been eliminated. In response, many are quick to highlight that the microwave background has also been measured by the WMAP and Planck satellites.
Stephanie.
Still here.
Okay.
Cool.
Just making sure.
Just had to make sure that things didn't burn on the stove.
No, yeah, that is very important.
Yeah, I left the oven with a pizza in it on the other day.
And the fire department shows up, and that's never any good.
Yeah.
No good.
Those satellites were positioned around.
So this is what COBE produced. COBE produced a measurement at at all of these different, at every point that has an error bar, it produced a measurement of the absolute like magnetic intensity of the CMB, and and it was an orbit around the planet. It was in a polar orbit. Like it had a lot of different Earth-like environments that it was sampling over, and noise subtraction is like the thing that they spend all their time doing, is understanding and accounting for the various sources of noise. Because when you look out into space, you'll have a lot of signals coming from our own galaxy and from Earth and from all sorts of things. Not so much the ocean, though.
In response, many are quick to highlight that the microwave background has also been measured by the WMAP and Planck satellites. Those satellites were positioned at the second Lagrangian point, as you can see here. This point is located about 1.5 million kilometers from Earth. Lagrangian points are locations in space where the orbital motion of the body and the gravitational forces perfectly balance each other.
So the James Webb Space Telescope is also in a Lagrange point somewhere. I don't know which one it is off the top of my head. But COBE was the first like big CMB satellite. Then they sent out WMAP, which stands for something I can't remember, wide something, whatever. And then the Planck satellite, like a bit over a decade ago, was a more recent one. And those two did differential measurements. They didn't do an absolute measurement, and at least they weren't designed to produce an absolute measurement of as high accuracy. So they didn't publish one because that's not what the devices were designed to look for. And he doesn't seem to understand this.
As a result, any object placed at a Lagrange point will tend to...
Also, these are millions of miles away. Over 1 million miles away from Earth. They're way further than COBE, and yet all of their measurements are completely like consistent with what COBE found.
to hover about that location and stay fixed relative to the Earth. There are a total of 5 Lagrangian points. Located at L2, both WMAP and the Planck satellites were shielded from microwaves originating from the Sun or the Earth. Again, the satellites had a heat shield to guard against electromagnetic heating. However, neither of these two satellites ever measured the blackbody curve associated with the Pyrrhus horn. They only...
I don't entirely... Oh, he means that they didn't do a direct absolute measurement of each little point. So, like, in this plot that was down here, like they in steps of 0.5 millimeter at every wavelength, so 0.5 millimeter, 1 millimeter, 1.5 millimeters, so on, up to like a bunch of millimeters. They measured the absolute like intensity of the microwave hiss that you see, and these ones didn't do that. Instead, what they did was they had 2 channels that measured the hiss and at slightly different points in the sky and subtracted the 2. So you got a super really nice measurement of the differential thing, but the absolute scale, for Planck, it was only designed to have an absolute accuracy of 0.5%, which is fine because that's not what it was trying to do. It was trying to say this part is brighter than this part by a part in 10 to the negative 4, even if we don't know what the absolute value is, to better than a part in 200. And that's fine.
If you like, I can share a comparison of CMB results from COBE, WMAP, and Planck.
Yeah, sure.
Yeah, if you have it.
So yeah, I do. And there it is.
Okay, what are we looking at?
So, go for it.
No, you go for it. You're the...
So what we're looking at here is on the left you have COBE, And COBE was designed to make an absolute measurement of the spectrum at all of those different points that we saw in that plot with those error bars. What WMAP and Planck were designed to do was, we already measured the absolute black body spectrum very precisely. We can fit it out to like 4 decimal places, which for a thermal effect is crazy. I mean, thermometry is very rarely done to that level of precision. It's very difficult, and it's because the CMB came from an almost perfect black body. So what WMAP and Planck are doing is they're looking at 2 spots in the sky, and they're saying, okay, this spot is a little bit hotter than this spot. The microwaves that are coming from there are a little bit shifted over than the ones coming from over here, but very, 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 very small. Basically, COBE measured how heavy if we were measuring something else, say we're measuring this book, okay? COBE can measure exactly how many grams this book is to some part in a small number, like 1,000 or 10,000th or something like that. Whereas, but it can't tell, but it's sort of coarse graining over the whole sky. It has very poor resolution. WMAP and Planck, they don't know how heavy the book is, but they know that, like, this piece of paper, they can tell that this piece of paper is a little bit heavier than this piece of paper.
Wow.
It's a different measurement.
Okay.
It's a different measurement, but you still have to get the thing roughly right. Like it's like using a balance instead of an absolute scale. A balance compares to another thing, and an absolute scale has to be calibrated to some absolute sort of reference. But yeah, that picture gives a very they're measuring different things.
Okay.
Measuring basically different temperatures. They're really, really tiny.
Tiny, apart in 10,000. They're so.
And what you're looking at, the reason for trying to refine that is because the CMB is reflecting the state of the universe at what, how 200,000, 300,000 years after the Big Bang?
Something like that.
Something like that.
Yeah, it's the number I'm pulling out of my butt is 350,000 years after the Big Bang, and it shows sort of the temperature anisotropies, the fluctuations in the temperature, and all of that eventually provides the framework for the structure of the universe. Yes. As we know it. Because those little tiny differences in temperature, differences in energy is mass. And so these little clumps just sort of all come together, and we wind up with galaxies and stars. And all that other stuff. And that's where it came from. It's pretty remarkable. Yeah, it's super cool. Anyway.
Okay. Where's your video?
It's here. Whoops, sorry.
Acquired data linked to microwave anisotropy maps. Moreover, as you will learn soon, WMAP was a differential instrument, always taking differences between 2 channels. It subtracted the signal observed from one region of the sky from that being sampled in another region. As a result, it was incapable of obtaining the equivalent of the Fearus curve. As for the Planck instrument, it used pseudo-differential radiometers at low frequency. These should have been able to confirm the COBE-Fearus findings, but they never did. We will cover all of this in greater detail in later videos, but for the present, let us return to the COBE-Fearus results, as they represent the only blackbody measurements ever obtained from space. Now, as a point of interest, the results of the COBE-Fearus horn are often plotted in different ways.
And the reason for that is so basically, the Planck satellite measured the deviations from this line. COBE measured the line. Planck measured the deviations from the line. Fundamentally, you have to have the ability to measure the line at sort of some level in order to measure deviations from it.
Right.
It's just that it's the example I gave with a scale. If you have two enormously heavy objects and one's slightly heavier than the other, you can tell that even if you don't know exactly how heavy they are. So the idea that the data would make any sort of sense if it wasn't on top of this line is comical to me.
And this can lead to some confusion for the novice. So let us go through this briefly. Most commonly, you will see the Kobe-Furious results plotted in wave numbers, as in this figure. A wave number is exactly what the name implies, the number of
I hate
waves
wave
per unit
numbers.
distance, typically the centimeter. Symbolically,
there are a lot of different units that you can give that you can do it in wavelength, you can do it in wave number, you can do it in wave frequency, and wave number is my least favorite because it's technically a frequency thing, but it feels more like a wavelength thing. Like this plot has the same shape on a wavelength plot and a completely different shape on a frequency plot, even though this is ostensibly a frequency. It drives me crazy, and it's also measured in inverse centimeters, which I just don't like. Give me the actual wavelength. Don't give me the inverse of the wavelength.
Is expressed as nu bar and is
Oh wait,
equal
is that
to
what he's
1.
doing?
Yeah, but that's not his fault. That's fine. This is inverse centimeters are a very standard spectroscopic notation.
Okay.
It's just one that so I don't do spectroscopy
Nor do I.
in a classical sort of spectroscopic sense. I do spectroscopy all the time, but it's not. What I'm doing is the x-axis of all of my plots for spectroscopy is always frequency. It's always like in megahertz or kilohertz or something, because that's the kilohertz is a unit of frequency, and inverse centimeters is not a unit of frequency, even though it technically is, but it shouldn't be, and it bugs me.
Over the wavelength. This leads to a scale in reciprocal centimeters. Furious data can also be plotted as a function of wavelength. For
See?
instance,
It looks exactly the same as the wavelength plot. And this one makes way more sense. This is the wavelength of the radiation. 1 millimeter wavelength means that the light, it has an electric field that goes up, and then down, and then back to 0. And that distance is 1 millimeter. Very straightforward.
it's millimeters, as you can see in this figure. Finally, the Furious data can be plotted in terms of frequency, typically gigahertz. Of course,
These two plots are showing exactly the same data. They're just different units.
all these plots can have differing y-axes. Typically, one will display intensity, with the units involving either joules or ergs. So do not let all these depictions bother you. They are all representing the same thing, namely a black body spectrum with an apparent temperature of 2.725 Kelvin. Now the Furious curve is.
So I want to give Dr. Robitaille credit here, and by the way, I'm not saying that sarcastically. I'm of the opinion that if somebody earned their PhD legitimately, until and unless you can, and this might be self-serving, until and unless you can show that they didn't earn the degree legitimately, even if they completely screw up and are a terrible scientist later, if you forget how to read, you don't lose your high school diploma, right? Same kind of logic. So I am not being sarcastic when I refer to him as doctor. I will never refer to him as a physicist, though. At least not an astrophysicist.
Isn't Kent Hovind a doctor?
Oh, no. See, Kent Hovind did not earn it. Are you trying to give me a stroke, Maya? Kent Hovind did not earn a PhD.
No, yeah, Deffer's been over his PhD many times. Or, I don't know, his, like, kindergarten science project.
Yeah, if I ever call Kent Hovind a doctor, I'm absolutely being sarcastic, which is why I wanted to point this out here. Also, I want to give Dr. Robitaille credit. Everything he said in the last minute and 30 seconds, roughly, has been correct and pretty well stated, honestly.
Okay.
also referred to as the monopole of the
So what's
microwave
it?
background.
So does he have a problem with any of this, or is he just trying to like?
Not the stuff that he just said in the so from here, he has a problem with this, but he doesn't have a problem with this, or
Okay.
he's about to explain his problem.
Okay,
0.25
gotcha.
Kelvin. Now, the Fear's curve is also referred to as the monopole of the microwave background. That is often confusing for people, especially for those who understand that magnetic monopoles do not exist.
Yeah,
But in
it has
this
nothing to
case,
do
the
with
term
magnetic
is not
monopoles.
associated with magnetism at all.
Also
It
true.
is related to imaging. Scientific images can be expressed in terms of spherical harmonics. A monopole is an image component that has the same value everywhere on the image. Here is what the monopole looks like for one of the frequencies of the microwave background using moleweed projection.
Basically, the idea is that you can divide. If you look at a thing, you're going to have a part that is flat, and then you're going to have a part that fluctuates with some wavelength, and then another part that maybe fluctuates with another wavelength. And if you add all those wavelengths together, you can get any sort of curve you want, and you can do this with a three-dimensional view. It's what Fourier analysis is fundamentally. Like that is what it is. It's converting from frequency into time or spatial structure, and COBE measured this, but the other satellites didn't because that's
for
not
the
what they were
sky.
designed to do.
Such projections are often used to represent the celestial sphere in 2D. They trade off accuracy in angle and shape for accuracy in area. Now, it is possible, of course, to present monopole maps for each frequency in the Fourier spectrum. They would all look the same, but differ only in intensity, which
Yes.
is represented by a differing color. In any event, the Fear's horn was set to sample the sky over a phenomenal range from 3 to 3,000 gigahertz, or 1 to 95 reciprocal centimeters. The key point here is that still to this day, scientists have never been able to build a microwave detector which is sensitive over such a great frequency range. It is a physical impossibility.
So I found that perplexing, because it sounds like he just said they built this device that is able to measure over this range, and also it's impossible today to build a device that's able to measure over that range. And he's not wrong, but he said it in about the most confusing way that you could. Because the thing is, these satellites have multiple detectors that are sensitive to different sub-ranges within that thing. You don't use the same camera to take a picture of an X-ray as you do to take a picture with your cell phone as you do to take a picture of a heat spectrum like a snake or something would see. I don't know if snakes actually see heat, but so I don't know why he's pointing that out. It's just a completely unnecessary thing to go on
It stands to reason, therefore, that the performance of this horn was never properly documented on Earth over this range of frequencies prior to launch. I have also highlighted in this.
So what he just said there was they didn't test it.
Sounds sus to me.
Yeah.
Yeah, NASA spent millions of dollars to send something up into the space, into the heavens, to kiss the face of God, and didn't test the fucking thing. I mean, yeah, sure. Sounds right.
Sorry, I cut out for a moment there, I think.
You did,
Yeah,
but
but
you're
you're back.
I'm back? Okay. Well, hopefully all is good. Yeah, no, he says they didn't test it, basically, and it's there are certain subsystems. The whole thing operating together as it operates in space, you can't test because you can't get rid of gravity, and you can't make a vacuum chamber in a zero-G environment like that big. But you can test so many details of these subsystems that the thing he's complaining about, they totally tested it. It stands to reason they didn't properly calibrate. What are you talking about, bro? This is like if he turned on one of his MRIs and somebody said, it stands to reason that because you don't have a little guy with a camera inside each individual cell, that the image that you're reproducing is not accurate. It's actually, I think, a pretty good comparison at a high level, and it's why I'm astonished that this guy doesn't understand these things.
Is he working
This
for
video,
like a
I don't know
a
what he
think
does
tank,
now.
or is he's just really like being this daft over the internet?
Yeah, I think he's just being this daft over the, like, he gets he I mean he has videos on, like, on the Thunderbolt Project YouTube, which was another pseudoscience BS thing that Professor Dave responded to. Professor Dave does a lot of really, really great debunks, by the way. And he brings receipts, which, for like a live reaction like we're doing now, it's hard to bring the receipts as well. But
that the Ferris horn had a smooth interior and was therefore completely unable to prevent diffracted signals from being measured.
that's
In
dumb.
order to prevent diffraction into a microwave horn, the edges must be specifically designed with ridges. However, that will render the horn
real quick.
sensitive only to a narrow band of frequencies.
All right. I just want to point out here how rude Bree is being. She has a bunch of loyal followers in the chat that would love to hear her voice, and she's just being so selfish.
Free.
Get her butt in here.
Free. See? Almost the same, not quite.
Which is not what the Ferris team wanted. But what is more concerning is the apparent rejection of low-frequency data. Remember that the Kobe Ferris horn was supposed to be sensitive from 1 to 95 reciprocal centimeters. In fact, that is what was reported in the very first data disclosure in January 1990, as you can see here. But eventually, all data plotted for the region between 1 and 2 reciprocal centimeters is removed, as you can see in this figure. The reason that this is so concerning is that this involves a low-frequency end of the spectrum, that region most prone to the effects of diffraction, and also that region from which data should have been easiest to obtain.
That's an ignorant statement, I am sure. Somebody not I saw what Bree wrote.
What happened?
Apparently, in Bree's headcanon, she ships me and Professor Dave.
Oh.
Anytime somebody who didn't work on the design and operation of an apparatus says, this apparatus should be particularly good in this regime, they don't know what they're talking about compared to the people who do design and operate these things. Sometimes you learn later that things have weird idiosyncrasies. And you realize later that the data in a certain part of the spectrum you can't trust as well because there are systematic errors that you can't account for. And he's saying that he's blaming these systematic errors, and then when they don't show that data, probably because there is some sort of error, maybe. He contradicts himself, I feel like.
Fixon et al. Present a single sentence to explain the loss of data.
Also, this was 9 minutes of collection data, and it was presented at a conference. It's a totally different standard of rigor than what would be published in one of the most cited of all time astrophysical publications that won a Nobel Prize and is at the heart of, like, all of our cosmological data. Like, you don't compare the two. This was 9 minutes of data. This is like a year of data.
However, the measured emission is higher than predicted, particularly at the lowest frequencies. Keep this in mind, as it shows that not all is quite right with the Kobe-Ferris data. As a result of all this, the Ferris horn is not immune to detecting microwave signals originating from the oceans of the Earth. Beyond the Ferris horn, the Kobe satellite also had 6 differential microwave radiometers, or DMR, with 2 channels each, operating at 31.5, 53, and 90 gigahertz. Each of these pairs of radiometers measured the difference between two regions in the sky separated by 60 degrees. It was from these instruments that COBE first reported the famous anisotropy map seen here. We will return soon to the anisotropy maps when we discuss the WMAP satellite. Before that, however, in the next video, I wish to finish with the monopole by re-emphasizing the importance of the lattice in obtaining a blackbody spectrum. If you enjoyed the video today, promote the channel, mention the video to your local astronomy club, support me with a like, and subscribe for more videos as we look more closely at the sun, the stars, and beyond. Comments are always welcome down below, and I'll see you soon on our next video.
I don't like
So-
this guy.
His arrogance is overwhelming. It's just absolutely stunning to me. But a lot of these things come from some fundamental misunderstanding about the physics that's at play here, which this video goes he explores some of his own ignorance without meaning to.
So how does he derive a black body curve from the ocean?
I have no idea. So there
I mean, the
is.
data's there, right? I mean, this
Yeah.
the data's there. What does the effing ocean have to? You wouldn't be able to derive a black body curve from. You wouldn't be able to derive that data from. I don't know. What's he getting at here?
In this video he'll talk about how you need a lattice or something to cause a black body. That's not true. What you need is thermal equilibrium. I have a list of the things that you need. Okay, I prepared a list. You need like 4 things, according to what I was just randomly thinking, in order to derive Planck's black body law of radiation. And yeah, so I pulled up. These are notes that I have from grad school, where I went through in painstakingly detail, and I derived this in a way that I would write down so that when I had to figure it out again, I didn't have to figure it out again. I could just go to my notebook where I derived it in all of its detail and be like, yes, I understood every step of this at one point. Just because I can't do it at the drop of a hat now doesn't mean I didn't understand all of it.
But on that list, Dr. Tapioca Weasel,
Yeah.
Was there water there anywhere?
No, so water is on none of these items. None of these items is water. We have the Boltzmann factor. Basically, the probability that you're in a particular state is proportional to E to the negative thing of your energy. Energy conservation is the second thing. The fact that photons are not conserved, you could have any number of photons you want, and the fact that E equals h bar omega. This isn't Planck's law. This is, I guess, the quantization of. This is what Einstein won the Nobel Prize for, and he doesn't disagree with that. I don't think. I mean, who knows? But you don't need a lattice, which he's going to talk about how you need a lattice because the models that you use often talk about it. It's not really clear. He never actually makes a coherent point about why you need a lattice, in my opinion.
Hello everyone and welcome to Sky Scholar. We now return to our analysis of the microwave background. For the time being, let us concentrate on the monopole, namely the blackbody spectrum, which we presented in the last video. I have often stated that in order to produce the blackbody spectrum associated with the microwave background, one must first have access to a vibrational lattice, as you can learn from this 2003 presentation. It takes more than a simple thermal equilibrium.
It does not. It only takes thermal equilibrium. I flashed through the derivation. It's not something that is particularly suitable for us to go through right now. It requires statistical mechanics and an understanding of the Boltzmann distribution, which is experimentally grounded. Boltzmann's constant is named after Boltzmann because he did a really, really hard experiment where he showed that the probability of an energy state depends on the energy. And sorry.
A physical entity is required to generate the photons. Now, the vast majority of physicists will disagree with that statement. Most astronomers, for instance,
Yes, we will.
believe that thermal equilibrium is enough, in large part because they have never thought about the problem.
You do. So he is very technically right in a certain extremely uncharitable reading of what physicists mean. Yeah, you do need some way for the photons to interact in some way with their environment. You that isn't just reflecting. They need to be. You do need to have absorption and emission.
But if you follow this channel, you are familiar with the extensive series of
here you go,
videos
Dad.
that I've released.
Here's a question. Here's an answer they could understand.
What are Dr. Microwave's qualifications?
Yes, apparently he's an actual doctor. Who knew?
Yeah. So what? Where is his?
I joined the Department of Radiology in 1989 at Ohio
State.
Ohio State? Yeah.
Yeah, Ohio State. Yeah, he worked at Ohio State from 89 to 2000 as a director of magnetic resonance imaging research, and he produced some really major good work in that field. And then he was asked to step down because he began to promote theories that were outside his realm of expertise.
Yeah, for example, I'm reading here, this is the Ohio State Department of Medicine.
They totally canceled him. What a bunch of libs.
Yeah, but I don't actually know what his either. I don't know. It's possible he's an MD, but MRI is pretty physics heavy.
Kirchhoff's law stands at the very heart of spectroscopic analysis, not only in medicine, but also in fields as seemingly remote as astronomy. Here we are. For me, revisiting Kirchhoff's law of thermal emission has resulted in questioning many established ideas in astronomy, including the origin of the microwave background and, most importantly, the nature of the sun itself. That is because the standard model of the sun relies on the validity of Kirchhoff's law in order to justify a gaseous state. Conversely, if Kirchhoff's law is not valid, then the sun cannot be gaseous in nature. Along these lines, I have recently advanced 40 lines of evidence that the sun is comprised of condensed matter.
Specifically, I believe liquid metallic hydrogen.
Steph, the chat wants to know if you can turn it up, turn your microwave. Oh my God, your microphone up a little bit.
Yeah,
right?
Please turn the microwave up.
He thinks the sun is made out of liquid metallic hydrogen.
I thought maybe condensed milk is, but maybe not.
It's remarkably dumb.
To Kirchhoff's law and black body radiation.
Also, I want to say, so he has a video here called Stewart's Law. That is, like this is a thumbnail for a different video that he's advertising here. Stewart's Law, which he thinks that he has quibbles with exactly the formulation of Kirchhoff's law versus. I don't know if I pronounced that correctly, by the way. That's just how I was taught. Kirchhoff's law versus this guy Stewart's law, who I haven't said. It's kind of a pedantic issue that I don't think matters particularly much. But he spells it Stewart up here, And then here we're in the section of Stewart's law. If you look down at the progress bar, and it's spelled a different way, and I just noticed that, and like I thought that was mildly funny.
Most physicists cannot even state Kirchhoff's law properly. They often confuse Planck's law with Kirchhoff's, unable to see the tremendous distinction between the two. At times, they cite Stewart's law as Kirchhoff's law, not realizing that they are not the same. So before we go too far, let us make the subject clear. Stewart's law states that in thermal equilibrium, the emission of an object will be equal to its absorption. Of course, this is provided that no convection or conduction is operating. You can learn more about Stewart's law in this video. Unlike Kirchhoff's
It's pretty straightforward conservation of energy kind of stuff.
law, Stewart's law was derived from experiments. It is not simply deduced from theory. As for Kirchhoff's law, it extends much beyond Stewart's. It states that in the presence of temperature equilibrium, the radiation within any rigid opaque cavity will always be of the same nature. That radiation will be independent of the nature of the walls and depend only on temperature of observation and the frequency sampled. In other words, Kirchhoff advanced that blackbody radiation will be found in any rigid opaque cavity, provided that equilibrium is present.
Like I said, it's a bit of a quibble. I think he's wrong, but I think he's wrong in a way that, like, you can, if you go back to the original sources and you find the way that somebody originally formulated their law, like, it might be slightly different from how people tend to use it nowadays, because, like, I don't think that's technically correct. That's not really what it's about. It's more about
law this way, where
it's more about what goes in equals what comes out. That's really the core idea of what's going on here. Is what goes in is what comes out, and and when it's not, actually there's a ratio thing, and it's this universal thing that depends only on the temperature, and that is true.
wherein the emission observed from a small hole peering into a cavity is dependent only on temperature and frequency. Kirchhoff did not know the
If you idealize the system, in a real system, there are going to be limitations to that statement, because I mean, if something goes in and then it bounces off a little piece of reflective material and it comes right back out, like, that's not going to be the same spectrum as a black body. By the way, a black body is just a body that doesn't reflect; it only emits. So, yeah.
functional form of the radiation, but he advanced that it would be independent of the nature of the walls. At the same time, Kirchhoff's argument was entirely theoretical. He had no experimental proof for what he was advancing. On this basis alone, his paper should have been rejected, yet it eventually became a law of physics.
That's not, I mean...
Oh, but... it should have been... But it's a law of physics, but okay.
That's such a crackpot thing to say.
Kinda.
I mean, it's like it has no theoretical, it has no experimental justification. Like, what do you mean? Yes, it does though. Like, you can. Okay, and also, Kirchhoff was before Planck, and Planck's law is the more robust version of it, and I've derived Planck's law, as I said. It's in the notebook. I don't understand where he gets this idea. Also, theoretical physics is still physics. Just saying.
One would think, exactly. One would think that the theory says you do this and this should happen, and then you go out and you look and you do this and by gum that happens. Otherwise, the theory's the law ain't no law, right? You know, I don't get it, really.
I heard theoretical physics being actual physics is fighting words.
There are contexts in which you can sort of, you can find people who will have that fight. 99% of the time, no, you're not going to have that fight. Theoretical physics is totally physics. Where people start to disagree, though, is if things like string theory are even theoretical physics.
Hmm.
They are. It's also all of it's a continuum. It's all of these things have different levels of rigor, of falsifiability, of domains of validity, of their usefulness for making concrete predictions for potentially doable experiments now versus potentially doable experiments in the future. Um, yeah, like gravitational waves were predicted back, in some sense, back in the 1910s. Because in some sense, the theory of general relativity predicts them, and the theory of general relativity had its sort of foundational stuff figured out before 1920, and yet they weren't discovered for all that time. Does that mean that Einstein wasn't doing physics? No, that's
It was literally 100 years on the dot. Really, I mean,
yeah. It was,
Einstein
you're right.
said it was
Pretty
yeah.
close.
Uh, Einstein said there you there are definitely gravitational waves out here. That's implied by the nature of the theory, but we'll never see them.
Yeah,
And then
exactly.
the experimentalists figured out, hey, we can do this, and maybe we'll see them. And sure enough, we did.
And it took a long time. It took like 40 years. LIGO was in development from like the 70s until and the first 2016, right? Yeah.
Yeah.
And I mean, Higgs boson, that was from the mid 60s to 2012. Bose-Einstein condensation, my advisor won a Nobel Prize for being the first to observe it, and he observed it in 1995. Almost about a little less than 70 years after it was predicted by Bose and Einstein. Like, it's insane.
But in science, laws stem from observation and experiment, not mathematics. Worse still, Kirchhoff's law has
What
not
the
stood the test of time, even in mathematical terms. There is
Law is not a well-defined concept in the sciences. The things that are called laws are whatever. You know what? The best way of defining a law is, and I might get some pushback from other people. I don't know, but a law is whatever everybody calls a law. Like honestly, if you hear a word that describes a model and that instantly sets all these preconceptions for you, you need to loosen up a bit, because guess what? Sometimes things are called things for historical reasons. Yeah.
There's no valid theoretical proof of Kirchhoff's law, and there never has been. You can learn more about this problem
That's
in
just
this lecture
false.
and in this paper, where Planck's derivation of the law is shown to be invalid. Next, what about Planck's law? What Planck did was provide a mathematical form for the blackbody radiation curve. Planck's equation is clearly accurate and yields the correct answer. However, because Planck believed that Kirchhoff's law was correct, his work remains incomplete.
Why is it accurate then?
What the fuck?
It's accurate, but it's wrong. Why
Now,
is
laws
it
have
accurate?
consequences. It is because of Kirchhoff's law that astronomers and physicists believe that they can obtain a blackbody spectrum from the universe without the need for a physical lattice. Kirchhoff's law has enabled astronomers to argue that
Also because we know when we measure these systems, the law holds. That's why we think the law is accurate, I would imagine.
stars are gaseous plasma devoid of lattice structure, and that black holes will be able to produce Hawking radiation through pair production. In addition, because of Kirchhoff, Planck himself believed that blackbody radiation was completely independent of the nature of the walls, despite the fact that he always had recourse to a carbon particle in his text on the subject, as was reviewed in this.
Yeah, I don't think that's a fair discussion of what Planck believed.
Paper.
And this is the problem with people like this, is they will say things and I don't even know whether or not to give it any credence at all, because When he made the comment in the last video about how Kobe does not Kobe, how Planck does differential measurements, and they've never released a direct absolute measurement, I was like, well, that might be true, that might be false. I have no idea because I can't trust this guy, and I had to spend time to figure it out, and it was technically true, but for reasons which I would have been able to tell you 95% accurately before I even did the research, why? Because it's not designed to do the same thing.
As a result of all this, Planck's equation is the only expression in physics which has never been linked to a physical cause, as I discussed here.
And that is insane. That doesn't make any sense. Planck's law of radiation says that if you have a thing at thermal equilibrium, it's got some temperature, you're going to have photons being emitted from that. If it's a perfect absorber, photons are going to be emitted from that with a particular spectrum. How is that not a physical system that is being described? Is a photon part of a physical system, Maya?
I would go with yes. What is?
Yeah.
I don't understand what his problem is though.
His problem is because the derivation uses a particular. So, at a high level, I think his problem is basically that the derivation uses a particular model in order to compute the density of states that is available to the system. And because that particular model is not always applicable, therefore the conclusions are not always applicable, even though all you need to have is have the density of states be sufficiently continuous, then because of energy conservation and photon number non-conservation, and this, you can derive Planck's law. You don't need to know exactly how each and every photon was produced. You just need to know the statistics. That's what statistical mechanics is about. It's about being able to make statements and conclusions, which are absolutely experimentally verifiable, of a large system without necessarily knowing the precise microscopic physics of each individual thing. Because.
No, yeah. Just put a period right there. Because.
Yeah.
It is true that the equation correctly gives a blackbody radiation formula. However, though Planck used oscillators in his derivation, he completely removed the need for a physical oscillator in accounting for the spectrum you see. If you believe in Kirchhoff's law, you do not require the oscillators. This has permitted astronomy to evolve without any need.
You need to have thermalization. His point is that you need to have explicit thermalization. That is true. Everybody agrees with that. Nobody disputes that. It's just that part literally goes without saying in these contexts. It literally goes without saying.
Physical reality. Blackbody spectra could be produced with a pencil using theory alone, provided that the scientific paper, at least at some point, invoked thermal equilibrium. Yet in order to obtain a blackbody spectrum in the laboratory, physics must have recourse to a nearly perfect absorber. Graphite and soot are often used. One would not build a blackbody from silver.
Yeah,
and the reason is simple. You need a lattice that can both absorb and emit radiation in order to get a blackbody spectrum.
This is true. Not all objects are ideal blackbodies. It has to be a perfect absorber for it to be an ideal blackbody. For something to be a blackbody, it has to be able to absorb any photon that you send into it. That's what makes a thing black, is it absorbs all the photons and it doesn't scatter any photons. If you take soot and you heat it up until it's glowing red, that is still a black body because it is not reflecting anything. It's emitting it, but it's not reflecting it. And that's like a really important thing. And silver is a fantastic example of something that is not a good black body because, it's if it's hard for a photon to be absorbed, it's hard for a photon to be emitted, because basically of time reversal symmetry, or at least that's one heuristic that I think is pretty helpful. And so silver reflects really well, but it doesn't absorb really well because those are opposite things.
Mm-hmm.
spectrum. The graphite and soot lattices meet this requirement, but silver does not.
Soot is not a lattice at scales larger than a few nanometers.
As polished silver is nearly perfectly reflecting in the infrared
Hey,
and
Doc.
microwave.
Care to
If you send any
wager a guess at this answer?
Oh man, so I haven't read the paper that came out a while back, and I didn't even watch all of Dr. Becky's video on it, so I would highly recommend people go and check that out. But apparently there was a paper that thought basically that dark energy was tied to the mass of black holes, and when somebody explained the Cliff's Notes version of it to me at work, it made a lot of sense. Whether or not it's right, not my field. We don't know what dark energy is, though. Like, that's like one of the real screwed up mysteries of physics and of cosmology. But I mean, I think the first papers about it were published in like 1998 or something. It's a pretty
What? What it might be made up of? You mean?
No, that it was a thing, like that you need to add this new term, basically, that the universe's expansion is accelerating.
Oh,
Yeah.
dark energy. Yeah.
Dark
It was
energy,
98.
yeah.
It was 98. Yeah, that's right.
So that was 98. That's like pretty like recent, all things considered. And no, we don't know what it is. We don't know what dark matter is yet either, and that idea has been around for significantly longer, around
Yes.
a little over twice as long now, I think. Maybe 3
Goo-
times.
Google Fritz the Wiki.
Yeah. But yeah, we don't know. It's possible that somebody has a model that is correct right now, potentially. Hey, Peter.
So here's the thing. It's like Max Planck died in what 1947. It kind of it's the guy at the very center of quantum physics.
He was the guy at the very beginning of quantum physics.
Yeah, I mean, just came up with a whole bunch of stuff that is responsible in large part for what we're doing today, or at least what we're able to do today. You know, like
Yeah.
transistors, that kind of thing.
Oh,
Seems like some of his ideas are pretty good, theoretically grounded, and hasn't gone wrong yet. So I don't understand.
I don't know.
Radiation into a
what about the
graphite
great
cavity.
attractor?
So that's like a thing that apparently the entire like local area of the universe is like zooming towards.
Mm-hmm.
And I don't think we know what it, but maybe we do now. Maybe it's just a bunch of other galaxy clusters and stuff that we've been able to image. These are the great attractor is something that apparently like exists at like cosmological scales, like galactic superclusters and stuff. Things that are sizable, like noticeable fractions of the entire observable universe. That's what we're talking about. Objects on like that scale. It's hard to do those measurements. So yeah, funky.
So the secrets of the universe have not been unlocked, is what you're saying.
I mean, a lot of them have. right? Like we have like lasers and we have lasers and transistors. You have to understand a lot of funky things about the universe to have lasers and transistors work. Like it's not straightforward. You need to have like physics and then like a well built classical physics, and then you need to go beyond that paradigm and completely replace it. And yeah, it's.
Oh, do you know what she's talking about here? She's looking for a name for
No,
something. No, I'm
I
sorry. Are we
don't.
making you think too much?
No, I'm just.
The class has a lot of questions.
Yeah, no, I haven't. I'm not familiar with that. I wouldn't say that you can do it in like a proper tree where like you have one thing and then it branches off and the branches don't talk to each other. It would be all interleaving. It's
That makes
I
sense.
mean like the calculation, the derivation of Planck's law that I have requires statistical mechanics, and it requires the solution of the Schrodinger equation in a three-dimensional box. And those are two things. And for the record, the Schrodinger equation didn't exist, or wasn't known before the 1920s. So it certainly wasn't around when Planck published his thing in 1900. So yeah.
Immediately be transformed into black body radiation, as we saw in these videos. But if you do so in a silver cavity, or in a modern extremely reflective cavity used in lasers, you will get standing waves if the incident radiation is phase coherent. The radiation will never become black, which is great, for otherwise lasers, MRI cavities, and cell phones would not work.
That's
As a
and
point of interest
he's
to
not
physicists,
wrong, but it's a straw man of I think what he thinks the argument like is. They're not. Anybody who says it doesn't matter what the walls are made out of for like any observable measurement, like no, that's dumb. Like that's dumb. You have to be able. It has to be able to be modeled as a thing that will absorb anything you throw into it. And a laser cavity, a high finesse laser cavity, is emphatically not that.
perfectly reflecting cavities can never achieve thermal equilibrium through radiative processes, precisely because they are unable to absorb the incident radiation. They reach thermal equilibrium either through conduction or convection. The radiation which they contain remains completely dissociated from their actual temperature. That radiation remains a function of the radiation.
The main modes of the radiation, the modes that you're thinking about when you're thinking about a laser cavity, that's true. So what he's talking about here is where's my marker?
Uh-oh.
What he's talking about here is a similar thing to, so imagine that you have a string, right? And because a string is going to be a light wave, let me just figure out, is that going to work? That's going to work. And so light has a wave, right? And a string has a wave, and it's the same equation. If you have it fixed at this point and you have it fixed at this point, which are the two mirrors at the end of your cavity, then your light can only oscillate here, like that. It could oscillate like that. It could oscillate like that. But what you notice is that the ends are always fixed, and you have an integer number of troughs and hills. That's what he's saying. But there's also just going to be like other random stuff floating around, and that is going to be due to the black body radiation. Like at least once you subtract out the bits that are from other effects, like multiple things can happen at once in a physical system. You can have a standing wave, and then you can also have radiation that isn't necessarily just in that mode. It just won't be confined to that mode. And when it hits the wall, it'll be absorbed. Maddening.
reflection which
your
was
passion.
incident upon the cavity. Perfectly reflecting cavities may or may not contain radiation, and that has absolutely...
They always contain radiation because they're always going to contain black body radiation. They're always going to contain that. They may not contain a non-zero quantity of photons in the allowed modes of the cavity, but that's a different thing.
nothing to do with their temperatures. The perfectly reflecting cavity can reach temperature...
Also, there's no such thing as a perfectly reflecting cavity, and that is not a minor point. It's
equilibrium. But such cavities do not contain blackbody radiation unless that radiation was placed within it. As a result, Kirchhoff's
it's placed within it by the things that are emitting things.
law is false. Kirchhoff's law required temperature equilibrium, as you can learn through this English translation of Kirchhoff's work. The perfectly reflecting cavity easily meets this requirement. However, the radiation which it will contain will, in general, not be black. Of course, Kirchhoff was unable to study the perfect reflector using phase-coherent incident radiation. He lacked network analyzers and electronic test equipment. But if he had been able to study phase-coherent radiation and lasers, he would never have formulated a law stating that radiation contained within all opaque cavities must always be black and dependent only on temperature and frequency.
He would have added a very slight caveat that, as I said before, literally goes without saying.
While being independent of the nature of the walls at temperature equilibrium. So there is a lesson here, and the reason why I spent so much time on this channel treating Kirchhoff's law. Change in astrophysics is inherently linked to recognizing that Kirchhoff made an error. We need a distinct physical lattice to get a blackbody spectrum. An opaque enclosure is not enough, as our silver cavities with their standing waves prove. Of course, in 1862, Kirchhoff had no idea that silver cavities will someday be supporting standing waves. In
I don't think he would have been that puzzled by that.
any event, the lattice which seems to work best on Earth to produce a blackbody spectrum is the hexagonal planar lattice which is found in graphite and soot. Such a lattice was never present in the Big Bang,
dumb.
and that is their problem.
That's
the
so
Big Bang
dumb.
lacks a proper physical mechanism to produce the photons it claims. As such, this...
Why did he never makes this point? He never explains why you need a lattice for the photons.
Look, we've already been through this.
will not
Because
survive the passage of time.
it's like,
And
you
the
know,
fifth-
in cinema sins, and it's just like, why would they do that? It's like to make the movie happen.
Yeah, I know.
careful re-examination of the requirements for obtaining a blackbody spectrum. Someday, someone will link Planck's equation to the physical world. The physical setting required to produce a thermal spectrum will be recognized, and that setting will be the vibrational lattice. So when the need for lattice structure becomes recognized, Big Bangs, black holes, and gaseous stars will no longer survive. That will be the first real...
He doesn't think that stars are made out of a plasma. I mean, he calls it gas, but he means plasma.
It means plasma, yeah.
Yeah.
explosion in
Wait,
physics.
he's not even
And
using proper terms.
No, but honestly, that one doesn't bother me that much.
Why?
Because
He's supposed to have like actual training in this.
yeah, but I mean, it's one of it's one of these sort of people get loosey goosey with the language. I don't. It just doesn't bother me that much when people say that the sun is made out of gas instead of a plasma, because like
I mean,
a plasma is most plasmas are ionized gases, right? Like I guess all of them in some sense are ionized
I don't
gases.
know what his. I mean, because like I think when most people think of a gas, they're thinking of something else, and I don't know what he thinks a gas is.
Well, he thinks so. To answer Peter's question, he thinks that stars are made out of liquid metallic hydrogen.
Oh, hey, Jason hit the nail on the head.
Yeah, it's really remarkable.
it will take
I
the
like
form
Carrie Ann's
of
answer
cataclysmic
better.
change in physical theory.
Liquid metallic hydrogen.
If you enjoyed the video today, promote the channel, mention the video to your local astronomy club, support me with a like, and subscribe for more videos as we
No,
look more
like
closely
stop the
at the
thing.
sun,
We're
the
not
stars,
doing
and
any of those things. hit my like button.
What now? I just subscribed to him. Oh wait, no, I better not do
Why?
that.
Why would you do that?
'Cause-
You're setting a very bad tone for the class. Hey, I sent you a thingy. It's somewhat of a palate cleanser, but it's something I can maybe understand better. It's the feather guy.
All right, let's do it.
Yeah, he's
Oh, I meant to.
decided that the Earth is a corpse, and I feel like that's something I can. I'm stupid. Like I'm not gonna pretend, but I feel like that's something I can follow along with a little better.
I will say though, I'm gonna give Pierre Marie a little more credit here. He's literally orders of magnitude more competent than this guy.
Oh yeah, but
Cool.
like, okay, listen to me. The stupid is more entertaining.
Yeah, I mean,
All right, let's do it.
all right.
Well, okay, my friends.
Oh,
this
it's
is gonna
Mud
be
Fossil.
Short and sweet. Everything
It's our friend Roger.
Yeah.
Oh.
you see here is related to or is biology. That right there, my friends, is what you call a tendon mat.
By the way, okay, audience, just yes, this absolutely is completely a different topic.
Yes, completely a different topic.
Not
So-
remotely related to anything that we were discussing before. This guy thinks that the Earth is made out of meat, basically.
Yeah.
Yeah. Well, you know, he got his degree from MFU. There you go.
No, this is just sheer fun. Nothing to be learned here. Anything that could possibly just like hit upon the truth is sheer coincidence.
Yep.
So,
This is the tendon. That little strap comes up and it goes through that tendon mat, through a little slot, and it has a ball attached to that strap. The ball is normally inserted into some socket in the bone normally. Now, or it could be under another tendon mat somewhere, but it's locked into that tissue. It's not supposed.
He just started in the middle of this thought, right?
yes, he started like right in the middle of a. I'm assuming right in the middle of a paragraph.
Possibly in the middle of a sentence.
Right.
Supposed
You
to
like
come
you
out
can't
of it.
tell what the fuck he's talking about. If like there was no descriptor on the video.
Yeah. Did he?
There's
What are we actually looking at? Does
um,
anybody know? Did he say?
I heard him say words.
This is an injury. That ball has pulled out, but this shows you what the structure is. There's
It's
a
probably
tendon
rocks,
strap
though.
to a ball. Now, that's inside of your body, magnified very, very highly. This is in Utah. Arches National Park. That is exactly the same structure, and that is the exact original
Exactly the
fleshy
same.
part. That
Wow.
is normally inserted.
So this has an arch thing, and also this has an
All over.
arch
And then
thing.
there's all this is
Therefore, the Earth is a corpse,
Indeed.
which
Indeed.
is the title of this video: Earth is a corpse and a body.
Erosion? No. What? No.
And it was written in
Corpse.
ancient-
That's it.
And it was
Oh.
written in ancient times because corpses and bodies are works of literature.
You would think.
Yeah.
One would think he could not be serious. And then
Yeah.
you
It's
watch-
like. Yeah. The Earth is. Yeah. You're right. It's not water or erosion or
No.
any of that stuff. It's some guy did it.
exactly. It's ridiculous.
Some old guy, big head of white hair, and flowing robes. That guy did all this.
That guy.
Oh.
all fleshy tissue. Everything I showed you
In Utah.
and everything I will be showing is biology. This is out in Utah too. Guess what that is? They call those a Moki.
Hold on. What do we think it is? He asked a question. The panel needs to give our answers. Okay.
I got an idea.
Okay, you go.
It's scouring from the Bonneville flood.
No, Stephanie. No, like, what part of the body of the dead Earth corpse is it? Okay.
Definitely a knee.
Oh, I don't
think-
know. I don't know. Looks like testicles to me. I don't know.
Testicles. Ah,
Sure, why
perhaps.
not? Looks
It looks-
wrinkly, you know. It's got all that stuff going on there, you know.
To me, it
And,
looks
yeah,
like
it's
black
just
lung.
Oh,
Black
maybe
lung?
that's it.
Yeah, like some black
Planetary
lung.
dandruff. Obviously.
Look at this.
Marble.
It's got to be a body part, not anything to do with you know.
Okay, what does chat think? Okay, so Spooky says it's cells. Paleo says it's a scab. Planetary dandruff.
Carrie Ann's in for the balls.
Yeah.
See that? That's good.
You see this stuff right here? That's flesh that
Flesh.
has eroded down into what's called mud. Underneath is the basement layer. These were the interstitial balls, and
See? Told you.
Well done.
above that was the skin. This was the skin of some enormous creature, and here's what it looks like.
An enormous creature with a rash.
Those are those balls. And these are the layers of skin that eroded.
Okay, so we got these nuts over
I'm
here.
telling you, man. It's like I nailed it. Nailed it.
These nuts
Nailed it.
right here are the same as these nuts right here.
Look, I told you. I told you. The stupid inside here.
Oh, God. Leave it to MFU. They get it right every single time.
Every single time.
Peter, we might actually get an answer to that question, though.
No,
We might.
Jesus Christ.
we're going to be going over all this. This is the interstitium. See the balls right here?
Oh, please don't.
That's the skin. That's the skin. This is in the United Kingdom. I think it's called Hunston Cliffs or Hunston Beach, something like that. But it's in the United Kingdom. And that right there is the fleshy stuff
Oh my
that
god.
has the balls in it. That lets you go back and forth like this and come back to where you're supposed to
Wow.
be. That's-
Maya, did you know about the second layer of hilarity with the balls in this video? Because this is top notch.
Oh,
This
yeah.
is top notch Roger content. Okay, he's talking about the balls in here and the balls in here, and you can use the balls with the flesh. And
Look, this is
Oh.
why
At
I
the top.
usually select the videos. I've got an eye for content.
I was having a wonderful time. I
You
just
were.
want to say.
You are. Everyone here loves your passion for physics.
Oh,
So
my
much. So
fucking
much.
word.
When you were doing serious shit, we had like 20 people in here. And then I was just like, I'm a motherfucking dumb fuck. I need to hear about fleshy balls in the earth. And I gotta tell you, like this last like 40 minutes here is going to be like high quality content for me.
After it
For me
erodes
in
and erodes and
particular.
erodes, it turns into mud and the balls. The balls are tough. The mud is just gush. So that's how the whole thing falls out. Now these are the Moki marbles. Same thing happened over here, only it's gone now. Well, everything's gone. This is what it looks like in the body. And this was just discovered 2018. All of that layering of stuff, all of this
Those
stuff.
are toes.
They really didn't know it was there before because by the
Yes,
time
they-
they got it, it was flattened out to a pancake.
Get a
I think I got
pedicure
something-
going
yeah,
on
here's
with
right
it.
here. Meet your interstitium, newfound organ. That's all that stuff. All these balls. And this is the fluid-filled highway that is really basically your immune system, and this is the layer of.
The fluid-filled highway is your immune system. I don't know what that means. I
Neither
mean,
does he.
immune cells, basically. The most important ones are right in here. And they keep you from being attacked through that layer. This is all, it all ties together.
It all
So
ties
this is not
together.
just about rocks.
Sure
it's not
does.
just about
You
history. And it's
shouldn't
not
have
just about
balls in your
giants. And it's not
intestines,
just
people.
about God and all of that stuff. It's
You're
about all
doing
of
it
that
wrong.
stuff.
I love me some Rocky
It's
Mountain
funny how those
oysters.
things work together sometimes. Look at this. This is a tendon in us.
Uh,
You have thousands of them in you. And then they
Can you
break
stop
down
for
to
just
these
a
little
second?
tiny fibrils, and here they are.
ah,
The
Look,
block, the block,
people.
the block, the block, and here's the
whoops.
blocks.
Wait. Yeah, okay, yeah.
Sorry.
People, you cannot do a drinking game. Like, I am not going to be responsible for your deaths.
Yeah, no, it's too much. Like, what are you gonna do? Like, every time he does like the mega dumb, like we're at 58. It's been 3 minutes. So, like, what do you want?
No, yeah. I mean, there's just so many drinks in here, and I'm just like, no, it's gonna. I love you all. Like, don't do this to yourself. All right, let's move on.
We're down here. And then they end up with a ball underneath. Here's what they look like at the very end. You see it? All those little straps come down to balls. And then there's a bunch of other balls that are down underneath that are just anchors that sort of give it structure so they can't pull out. And here's the way they work. Ligaments, tendons,
You're muted,
muscles,
Stephanie. Just so you know.
anthesis. The anthesis is right where it attaches into your bones or your muscle, your tendon, and so forth. It's the anchor part. And that's
Okay,
what
everybody,
these are.
cough.
And then they have
Cough. Uh,
Oh my fucking word.
these little balls are everywhere, 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 everywhere. And nobody's ever been able to talk about what, I mean, they're everywhere. They're all over the place. They're all over the world, these balls. Here's one from.
what? Why does he think these? What?
Well, now there you have it, right there.
It's a lot of balls.
Yep, old MFU,
Well,
big
here it is
party
right here.
school. I'll tell you
Right
what.
from there. That's exactly where it's from. Something right like that, which is a ligament. It attaches a bone to another bone. I show you that. So in
He's
other
got
words,
a feather to
this
tickle
little
his
ball,
balls
little
with. I
finger
can't
on your
believe
wrist.
it. Oh my god.
No, that's like his whole shtick is he uses the feather and like honestly,
Jesus. Oh no. No.
I love
Please
the
no.
feather. But yeah, no, that's really cool though. If that's real and not like a sculpture, like that's really cool.
No,
That
I mean,
is
it
very
is really
cool.
cool, but like, it's not.
And I bet the explanation is really cool.
I mean, like, it's not a joint that. I mean, what does he think it is? Like, something died and left. Does he think it's a fossil?
I think he thinks that they're like organelles or some nonsense or cells or something.
Oh
Uh,
my god.
Hunter
It goes between this bone.
Hunter Biden's laptops. I'm saying it's MFU here. Mud
It's
Fossil
MF, yeah.
University. Come on
Yeah.
now.
MFU, give the program.
Realize that MFU is not the Spartans, believe me. Not the way it goes. Give me a minute, I'll think of the name of the
they
team.
can rock back and forth. And those
This is a
are
good question, though.
well, you can see
He's
it
not
sticking
telling us
up
where
here
the
just
balls
a minute.
came from.
But that's
I mean, his stream of consciousness just hasn't hit there yet, you know?
Sorry, I'm overcome.
Oh man. Oh.
all right. Well, that was a ligament. Ligaments are different than tendons. Tendency
Yeah.
here runs from a muscle into your bones and so forth.
I
Ligament goes between bone to bone. See it? Bone to bone. And that's that little neck, and a ball was sticking up. One of these balls was sticking up in the air. Simple as that.
he had a ball sticking up in the air, and it's
All
as
right, now,
simple as
you
that.
know, I
That's how
just showed you
tendons
that
work. I don't
video
like.
with Bob out
No
there
idea
in
follows
Utah.
the previous
This is
one.
this is a tour company in Utah. It's called Mountain Based, I believe. And I am going to highlight tour companies in certain areas. I've done some in the Mideast, and they have
What?
corresponded back asking questions about how can you explain this? How can you explain that? And that's what I want. So I don't know about this company here.
I
This
think
goes
they're
back
asking
4
questions
years
about his mental
ago.
state.
And
Like, that's fair enough. Uh, well, now I feel bad almost, but no, I don't think so. I think it's just like supreme confidence and ignorance, like Witsit levels. This guy is one of the few people who might rival Witsit,
Yeah, this is fair.
because that guy is nuts.
they don't have, they had one other tour company, Mr. Hunting's Adventures, chimed in on it, but that's about it. And but it's called Mountain Based.
What are we talking about?
About what they see, and like I said, I'm going to maybe do one on the other guy that talked about there, and see if we can get some interest in this. Here goes. Oh my God. This is what it.
So
Look at
mad
those
that nobody's
layers.
taught
Oh
him how
my
to
God,
properly
this is
screen share.
absolutely fabulous.
I mean, I feel like everybody has, though. Right? Like, that has to be one of the most shared pieces of information that, like, flows to this dude. Has to be, hey, by the way, you could do this instead.
Do you think it's the feather? So
It might be the feather, and I gotta
Could
say, if it's the
possibly be.
feather, I'm gonna respect that from a design choice like point of view. I think he can rock the feather. That's fine. But he's gonna have to use a digital feather, right? Because he's got
They're
to.
out
I
there.
mean,
Actually, one of my pointers is a feather.
Nice.
yeah, like it's. I think it works.
But then you have to learn how to change your pointer. And, as simple of a 3-step process as that is.
Yeah, I mean, he knows how to use YouTube both to view the video like he's doing now and also apparently to upload a video. So, I mean, I've never uploaded a video. What if I got lost?
Huh.
I mean, we could show you how to upload a video if you
I
would
don't know if
produce
I'm
some
smart enough for
goddamn
that.
You just be in touch with Mountain View Tour Company, and they'll give you a guide.
To the Grand Canyon, though, not to well, maybe.
There's a viral video of a hiker native atheist. If you can get that to me, we will all watch it tonight.
Whoa, yeah, what? What a dick. That's hilarious, though.
Seems cruel, really.
It's super cruel. It's super cruel, but it was sort of like funny in that way that when Randy Johnson hit that bird with a pitch. I mean, that was an accident, though. Kicking a squirrel off the ledges. He may not have expected to be able to hit it. Squirrels have really good reaction time. I'm surprised he hit the squirrel.
This is where a little blood is collected here, and it just stays powdery. The red blood runs right out. But this is a connective
I mean,
tissue.
this guy is literally a
There is so many
Neanderthal.
thicknesses and layers.
Red ochre, what the hell?
Yeah, no,
Layers of connective tissue in creatures' bodies. It's staggering. This is very good. And
Certainly
this is what I
is.
need is to have people right on site be able to walk up, look at this, sample it, put a little, hydrogen peroxide on it or some chemistry on it to see. Very simple stuff. Nothing that's invasive. Nothing that's going to
Put
destroy
some
the
chemistry on it.
atmosphere.
Put some chemistry and do the physics.
Oh, you know what? I think I found it. Ugh. I wonder if they'll let us play it though, because it looks like it's from a. Only one I found was like from a news show or something.
Huh. That's a good question. I mean,
Well, curious things from Hebrew. ADM, which is the 3 consonants that make up the word atom, can mean earth, man, mankind, red ochre, blood. See what else? Earthling. Interesting the way Hebrew works, isn't it? All you need is how do you put those 3 consonants together? A always comes first, D always comes second, M always comes last, but there are the vowels. So,
All right, Doc, did you see the video?
no, I didn't. Did you post it in a thing?
Yeah.
Sorry.
who's a serial killer? Oh yeah, okay. Gotcha now.
Yeah. I don't know where to look. Why isn't that popping up? Well, now it's because Discord isn't popping up, so I can't even check Discord.
What are y'all
Yeah.
looking for?
She sent me a link,
Let me see
okay.
if I can.
and now things are not responding on my computer.
Oh,
Paleo,
that's okay.
Paleo Logos in the chat doesn't have a link, but he does have a mink, which is pretty cool.
All right, let me see if this is.
Well, not anymore. He dissected
YouTube
it.
over the weekend is tough to watch. Look familiar? Park officials say this appears to be the edge of the Grand Canyon. Here you see a man wearing one shoe. In front of that one shoe, an unsuspecting squirrel. The man brings his leg back, and that is where we stop.
Sadly, you can probably guess what happened next.
Oh
9
my
News 5's Maggie
God.
Vespa joins us now with more. Maggie.
Guys,
what an asshole.
That's
Are they
rude.
Holy shit! I'm almost like scared to play more because like I wouldn't want like half the chat to start crying and.
Yeah,
We'll
I'm
come
like-
in here and get really mad.
All right.
Yeah, let's
So,
go
yeah,
back
that
to
happened.
let's go back to the blood over here.
Yeah, that's
See that up there? That's
exactly
blood.
what's
right
happening
there.
here.
Wildlife. But you see that? That came right out of there. That's where there was a pocket of blood. That's how creatures' bodies form. And that's how they're fed. All these people are looking at this and just in marvel, saying, well, how could this possibly have happened? Look at these layers. Look at this.
Most people aren't like that. Most people are like, how could this possibly have happened? Let me read the sign over here. Oh, that's cool. I learned how it happened. Right? Like,
The
This is a good
patterns.
question though.
right? This is what I'm saying. This is what I'm saying. I think these squirrels are like, when I first heard it, it didn't sound like an intentional thing to me. Because I could not imagine. It sounded like an accidental thing, like if a squirrel was running just at the wrong time, because they'll do that.
Yeah,
They'll totally run in front of you right at the wrong time and get run over all the time. That's like how they die nowadays. And their strategy for avoiding cars has actually evolved noticeably over the years in places. They their running behavior is different. It's no longer, if they do identify it as a threat, they no longer necessarily react to it the same way they would react like a hawk or something.
Right. Yeah, no, we have like in my area, because we just destroyed a lot of wildlife habitats to create suburbs. So the deer, they're just like walking down the street, and they'll just randomly block traffic to get their doe from a wooded area to like a pond or whatever. And they're just like, I don't know. They
Yeah.
all but like, I mean, they'll look at you and like almost dare you to hit them. Like, fuck off.
Yeah.
They have been getting a little bolder lately.
Yeah. Deer are.
But
I have
yeah,
like
no, that
complex
is not what
feeling about
happened
deer
here.
because
And
I
that
kind of
was
like
weird.
deer. But
All right, what's going on here?
The chemistry, if they're into the chemistry realm, with in awe, absolute awe. But to understand it, and then be able to go out and look at it, and be able to walk up to it face to face and touch it, and look at these arches. You know what that arch is? I can show you what that arch is. This Utah is
it, do you, is the
Oh,
arch is he going to show us his arch, and is it going to be full of balls?
very, very, very
don't tempt him.
spectacular.
I wouldn't dream of it.
Okay, I'm going to be going.
Man, that's really cool though.
Yeah,
Like,
no,
just
it
look how
is really
cool this
cool.
is. Look at all these
It is
weird
pretty
rock
cool.
patterns. It does kind of look like, I don't know, not just a rock. I don't know, but that's because it's a cool looking rock. Like some rocks be really cool looking, and that's why you have a national park named after them.
Over
Yep.
tour companies' videos about, and sort of highlighting them, and maybe it'll help them out, maybe it won't, I don't know. But at least I want to give them an opportunity to ask questions, and I want the opportunity to discuss what they see, rather than just have everybody in awe about, wow, look at this. And when you want to be in awe, just think about this. This guy or person, whoever it is, walking on top of this strap on that ball, which was a tendon enthesis in a creature, a creature that you can't get your mind around. Because this, you need a very, very powerful microscope to see this
What?
inside of a human being,
Oh, okay, okay. I just hadn't
Okay.
finished that.
as I showed
Hey,
you.
is
And
anyone
one
else
more
like
time. That, remember now,
disturbingly concerned about Roger's
look at the
level falls
size.
here?
And just
I'm worried he might have
but-
balls in his knees.
Yeah, it's I don't know. Where's the material proof though here, Roger? Get to that,
What do you mean? What do you mean? Look at it. It's obviously
It's obvious.
dead
It is-
animal.
It's a ball. It is known.
It is
just
balls.
think about the difference.
I don't understand
in
what he
that
thinks the people lived on though. Like,
compared
does he
to
think
this.
everything
This is
is
the exact same thing. Only
Well, I mean,
this one
yeah,
was
he
removed
says-
out of the socket.
he
That
says
one's still
Earth
in
is
the
a
socket,
corpse.
but all the socket has
Yeah.
eroded away. You can still
Like-
see the strap. Same
It
stuff.
was
He
written in
deliberately
ancient
chose the
times.
worst
Okay,
version of
maybe
his
not.
argument.
And that's
But,
coming right out of.
Groups of the
Oh,
dead
hey,
turtle.
Kaz.
You remember like what is the
And
one
that's
with
in
the
your
flat
body,
earthers where
so-
we're on a turtle's back or something?
This, and here's another one up here. Look at this. This is where an anchor anchored in here. Some little muscles from somewhere, I don't know where. But as it
Wouldn't
comes
you
out,
have to
see
know
this?
where,
This is in the
mate?
No, his logic is it's the
Failing?
most like it's one of the most cartoonish examples I'm aware of like real person examples of it looks like this, therefore it is this, like very simplistic way of looking at the world and doing geology or archaeology and thinking that, like the people who think that
Or open heart
because
surgery.
they think because certain things like Devil's Tower, I think, are actually old tree trunks because they kind of look like it, and like that's it,
Okay.
and like that's really dumb.
Abrupt transition. That's another abrupt transition. And that is as it goes into muscle. Then the muscle becomes kind of floppy. But
It's floppy muscle.
look at what it does do. It keeps these tight junctions. You see in here?
Like that, to me, it would make more sense if you were arguing that were like made by aliens.
Yeah. No, I was
Right?
actually just thinking that.
I was like, I don't know, man. That looks more like it was made by aliens.
Man.
And
Look, it's like it's so precise. You can't even get a piece of paper between it. It's
Yeah,
totally the aliens.
right?
When you were alive and moving, when this thing moved and was alive, these things all had to slide back and forth along with each other.
Maybe
and
these
not
are the muscle
separate.
cells.
That's what that Slurpee stuff is I'm talking about.
What?
We got a lot to look
Hold
at
on.
because you can
Slurpee stuff.
Was that a thing he mentioned earlier that I just like missed?
Maybe a
What, the
different
Slurpee
video?
stuff?
The Slurpee stuff.
I didn't hear anything in this, but
I
sorry.
haven't heard
didn't
anything
hear
previous
anything
to
in this
this
video, yeah.
about Slurpee stuff.
It's like
So
the
I'm thinking
glowy
maybe a
stuff
different video.
on like the Electron. The Electron's got like
Oh,
the
that's
the
horrible.
non-glowy part, and it's got the glowy part.
Oh, you know what?
You should
Cheese
check out
Cheese is probably right.
Dapper Dinosaur's series on him.
Slurpee
see
stuff
it
has
all.
got to be.
This is I saw all
Slurpee stuff has got to be a scientific term we're unfamiliar with.
I mean, I'm not gonna rule it out, because physicists like to have fun with their language, so you can get away with some pretty fun stuff, like nuclear pasta.
Nuclear pasta.
all this stuff before they
It's a real thing. Nuclear pasta is a real thing.
Sure.
Yeah.
even knew it existed. I'm not kidding you. They didn't know about interstitium. I could see it. I mean, I could see everything that's going on inside here. So I had a lot of questions, and I still do. But I got a lot of answers now. And I'm going to tell you something right now. You see this? These are tendinenthesis, and sometimes they grow with the crystals inside the center here, like this. And then they have breaks, and to where they have a different mineralization, and then it goes out to the muscle and so forth. Well, look at this.
The what?
This, my friends, is the same thing. Where is it? That's the same crystals. We're inside of one of those
same.
balls. And those are the crystals.
What is this?
Everything
picture?
small is just a small version of something big, you guys.
Oh yeah, no, that's apparent. What is this a picture of though?
This is a picture probably of like,
That never mind. I
well,
won't
it's a
go
cave. It's clearly a cave.
Okay.
Sorry. It's a big one. This is a dude, right? I'm pretty sure.
Yeah.
Oh,
with a
okay. I
cap.
see high.
Yeah, this is a big cave. I can't remember the name of it, and I was definitely on the Wikipedia for this exact cave. I'm pretty sure less than 2 months ago. But it's a really remarkable location.
Oh.
It's really hot in there.
Yeah,
And
Pragmatic Crystal is saying it's a crystal cave in Mexico.
yeah, it's super
Okay.
hot in there. It has like, well, I don't know. I think the humidity is probably like 100% all the time. But, that's not ice. That's rock.
Yeah.
So it's
Right.
stuff like that, and they form these huge crystals. I think they're some of the largest, like, intact crystals that have, like, ever been found, because they're in this cave that's just been locked in that sort of environment for a long time. But
So-
not as long as you might think. Like,
So this is the same as the last thing, and we still haven't seen what part of the body it is, though.
Yeah, but it is an extremely awesome example of crystal formation.
No, yeah. I mean, it's beautiful. I'm not
Yeah.
knocking that. I'm not sure
It,
what he's getting at.
he's saying because crystals are here and also crystals can form inside a cell under certain contexts, therefore the cave is a cell. I mean,
Uh-huh.
Those are just kidney stones, apparently.
Ah.
That is this.
yeah, that is this. That's what's going on right here.
That's that.
Okay.
See?
That's
Well,
okay.
Yeah.
Like
Okay,
they
then.
they forgot to put the little icon of the like little dude mining
Right.
or researching
Maybe it's
rather.
just too
And
small and
Yeah.
it's so far beyond the average human mind to be able to comprehend this.
That's
You
for
have to
sure. It
sit
takes a
down for while
unique
and
human
think.
to.
Don't just jump up and say, "Oh, that guy's insane." Well, that's a good possibility. Maybe I am, but that doesn't mean I'm wrong. If I
No.
could produce
No, you
evidence,
can, why
I'm
not
producing
both?
art.
You could be wrong and insane. Why
I mean
not?
the lack of evidence though, could possibly mean you're wrong.
Yeah. I mean, but
It's like, look, it looks
or
exactly like that. This is totally evidence.
oh man, at least here he has that. I gotta say, at least here he has the it kind of looks like that thing. When he starts talking about particle physics,
Oh, that was fun.
Yeah, that's
oh,
pretty good too.
like
Geology particle. He's got it. He covers the waterfront. This guy.
yeah, but there he's just it's just complete fan fiction.
Artificial intelligence saying, "Show me something that looks like this or that," and you could.
I don't know how did we get there in that sentence to the artificial intelligence is showing him something.
Look, we already
Make
said
it anything.
I think this stream and last stream, like, just sentences don't have to make internal sense, or he could start in the middle of a paragraph if he wants to.
I mean, it's his channel. He can do what he wants, I guess.
He does.
Yeah, you're not wrong.
I could say, "Show me people that landed on the moon with a mouse crawling up their back," and you'll see it now, and you could not, in any way possible, tell the difference.
Wait. Show me a picture of people landing on the moon with a mouse up their back.
Crawling up their back, yeah.
No.
Why
Okay. I don't think I will, but
why would we do that?
Well,
What is the
So
proof?
so it could prove something, or, and hear me out, it's a bold possibility, but it could be. You want me to pull out the whiteboard? I can write it. It
I
starts
wouldn't
with an
want you.
N.
No, you painstaking notes that you made all over the whiteboard. I would not want you to erase that for nothing. Oh wait, is that it? Is it nothing?
It's nothing. That's what's going on here. That's the answer. It means
and it was
nothing.
written
Real or
in
fake.
ancient times.
Yeah. I don't know. Did he ever get to this part?
No, apparently not. It's the written in ancient times part. It's like it's keeping us in suspense.
That's the problem with artificial intelligence. They can make anything fake. You can't fake this. You walk up, touch this, and put your tongue on that.
You gotta lick them. You gotta lick the
You
artifact.
gotta lick your
guys.
balls, absolutely, if you can.
You gotta lick the rock balls.
You gotta lick the balls. Maybe tickle them, maybe cuff them. Don't forget to work the shaft.
My God,
That's a whole different story than looking at pictures about stories about, because the artificial intelligence just make it happen now. And like I say, you could tell it to do anything you want. So I want a snake crawling up the guy's leg, biting a mouse that's nibbling on his ear while the guy screams, and it'll do it. And you'll never be able to say,
it's got anatomy right.
Oh my God, no! This guy is just hard up. Is anybody in here not
Wait a minute.
convinced? Get this man a woman.
I don't. How could you do that to her?
The guy's got a snake crawling up his leg, nibbling on his ear. I don't know. You would try that on Tinder or something. I don't know.
No,
That's the
seriously,
problem.
he doesn't need a science. He doesn't need to go to science channels. He doesn't need to go to Google. He just needs to go to Tinder, maybe Grinder. You know,
Maybe. Yeah, could
I
be.
mean, he's got some weird kinks and fetishes, and I'm not kink shaming. I am not. I'm just saying, if you've got a weird kink, Grinder is the place to go. I am nothing if not an ally.
Absolutely.
Yep.
We never found out where
I
it was
live
written
in
in
the real
ancient
world.
times.
Maybe
No, like I mean,
he's
you
got
think,
less. He's got 0 seconds. Sorry, I paused at the end.
no,
Yeah.
I mean, that's what I'm saying. Like he's like, no, we totally got proof of like, material proof. You will see. And the only thing that I saw was like, you got to walk up to the balls and lick them. Like,
Except for the mouse and the snake, you shouldn't have a problem.
all right, guys, what we've learned today is
Another
you know,
edition of MFU.
tickle the balls. Don't forget to work the shaft. Is what I'm gonna leave my.
Told you it
parting.
was a party school.
Yeah, I don't know how to get. Because last time I like kicked the speaker, it like kick tap all the way out, and I want to do that again. I know where I work my own stream because I'm a professional streamer. All right, all right, all right. I want to thank everybody for coming here, showing up. Love you guys so much. It's been a really rough week for all, and we just wanted to have a little bit of fun tonight. So I want to thank Steph for coming out and Tap. Dr. Tapioca Weasel, who are you? Where are you? Where can we find you this week?
Um, this is like mostly the thing that I do on like YouTube that you can reliably find me. I'm always in the chat at Dapper's Tuesday night streams. So yeah, definitely check out Dapper Dinosaurs Tuesday night streams. I host Bingo.
Yes, yes.
I think this week it's Matt with Maddie.
Oh, cool.
So, but Maddie's schedule is, a fluctuating thing because of the recent baby. So
Yeah, congrats to Maddie, because
yeah.
that's awesome. All right, Steph,
Yeah.
who are you? Who are you? Where are you? And where can we find you this week?
Well, I'm me. I'm probably going to be spending an awful lot of time trying to sew this week, and but I'll try to find some time to jump on Neil the 604 Atheist after shows and laugh just about as hard as we did tonight, but not quite. I'm not sure what else is coming up. I might share some thoughts on my channel, but we'll see.
All right, yeah, and I don't know, canceled some things just because I don't know, I felt my presence was better needed in the community, and I don't know. I just want to let everybody who came through know how much I love you, how much I appreciate you, and it's nice to know who your friends are. So we'll see you guys all later. Bye.
Bye.